Hello everyone, welcome to this session on DevOps. Today in this session we're going to understand why do we exactly need DevOps, and then move on to understand what is exactly DevOps. After understanding what is DevOps and why do we need it, I'm going to make you understand how DevOps exactly works using the various tools which are available in the market right now. Right? So guys, this is the agenda for this session. I hope it's clear to you. So let's move on and start with our first topic, which is why do we need DevOps?
In any tech company, in any tech team, you have two teams which basically contribute to a release of a software. The first team is called the development team, and the second team is called the operations team. Right? Now, what is development team and what is operations team? A developer is basically a person who develops the code, right? He would develop the code, and the code would then be forwarded to the operations guy, whose job is to basically test the code and put it on the testing server or the production server based on the requirement, right? Now, what was the problem here? The problem was when the developer developed the code and he forwarded it to the operations guy's system could not run the code which the developer has forwarded, right? So obviously the developer would have tested the code that he is sending on his system first, and only then he's sending, right? On successful operation on his system, he will only forward the code to somebody else who wants to test it, right? But it did not run on the operation system guy. It could be the problem of environment. It could be the problem that he has not installed everything which is required by the software. So he used to push it back to the developer saying, your code is not running on my system. Please check your code. It is faulty, right? But now the developer was furious. It ran fine on his system. And if that operations guy is not installing something properly, it's not his problem, right? It's not his job to go ahead and fix his system and then run the code, because his job is to run or develop the code which he is doing, and the code is running fine on his system, right? So it's the operations guy problem that he's not able to run it on his system, right? So these were some of the problems that were between the developers and the operations guy, and this was solved later. But before that, there was a lot of problem in team communication, and it solved and it caused a lot of inefficiency in the team, right? When we talk about lean methodology, we were talking about faster release cycles, eliminating waste, but this was a waste that we were not able to eliminate using lean methodology, right? And this was solved using DevOps. Right? Now the DevOps is what is DevOps exactly? It is not a tool, it is not a software suite. It's basically an idea, it's basically a thinking. And this thinking is obviously implemented using some tools. But right now, if you were to talk about DevOps, like I said, it's just an idea of working in a certain way that could solve the problem that we were facing between the development and the operations team. So if you were to draw some differences between what we were doing earlier when we were working without DevOps and what happens when we use DevOps, is that the traditional IT system was less productive, although it was very productive, as we saw in lean methodology, where we have eliminated everything. We have tried everything in our hands to solve it using the planning part, but there was still some room of inefficiency that we could not solve using planning, and that was solved using DevOps. So DevOps was more productive than traditional IT, right? And then in traditional IT, we had a skill-centric team, right? Each team was skilled in a particular territory, and we had a lot of teams in our organization which used to work on different things. Now in DevOps, what we do is the smaller teams are also specialized in different domains based on the silos, right? Based on the technology. So rather than having 4 people who are equipped or who are skill centric in one particular technology, in DevOps we had each person who was skill centric in a technology, right? So probably one person would know Kubernetes, the other person would know DevOps better, the other person would know Git better, the other person could know some other technology better. So we had silos like this, right? In traditional IT, we used to invest more time in planning. So when I talk about traditional IT, I'm talking about waterfall, agile, lean, both collectively, right? So there was still some planning involved when we talk about traditional IT. In DevOps, we are basically saying we do smaller and frequent release cycles, right? So we do smaller and frequent release cycles, as we saw by the end of lean and agile methodology that we are doing smaller release cycles, DevOps take the advantage of those methodologies and implements it in its own model as well, that we have smaller and frequent releases, but they're still smaller than what we were seeing in lean and agile methodologies. How is it? We are going to discuss it in the future. So DevOps still shortens the release cycle by the help of automation. It's a release cycles and hence releases software in even lesser days than, or lesser weeks than we had in traditional IT. If we talk about DevOps, guys, I would like to give you a fact that using DevOps methodology, you can have release cycles in a day rather than weeks or months. So every day there could be a release if you're using DevOps methodology to the fullest. Okay, so this was again a good thing. In traditional IT, when we were using waterfall model, for example, it was difficult to achieve a target or goal because the goal was set 1 year later, right? So there was a difficulty in doing that. Reason being, we could not foresee future, right? There could be some more problems that could be there while we are working on a project, but everything cannot be planned in advance. But in DevOps, because we are doing shorter release cycles, it is not that difficult to achieve a target or goal. It is easier to set objectives for a day than to set objectives for an year, what you're going to do, right? And that is why DevOps makes it easy for us or for your employees to achieve their goals or their targets. Okay, so this was basically the difference between what we had in the past, probably when we were using waterfall methodologies in the past, and what is the present, what we are able to currently achieve using the DevOps methodology. So guys, like I told you guys earlier, DevOps is nothing but a methodology. It is an idea, right? It is not a tool. It is not a software. It's an idea or methodology of solving the problems between developer and operations guys, right? Now, this methodology involves a life cycle, which, as you can see in the diagram, that the first thing that you do is you plan what you have to do, right? Then you code your way in, then you build the code. Building the code means if you have a Java file, for example, you'll have to create a jar file or an executable file out of that. So that is called building, right? So building your code, and then you will be testing your code. So what executable you have built, you'll basically test that code for any faults in the functionalities. And if there are no faults, you'll basically release the code to the ops team. Now there are two kinds of release, guys. There's an internal release and there's an external release, right? The internal release talks about releasing the software to a different team of the company, and this is what exactly is happening. Then comes the release phase where the developer guys release the software to the operation guys for their work, right? The operations guy will in turn deploy the software onto the target system. It could be a testing server which basically will test or do automated test on it, or it could be, you know, the production server where everything has happened, the testing has happened, and you're deploying it on the production server, right? So once you have deployed it, of course, now becomes the operation phase. The operation phase can be done internally, or it could be done by your customers, wherein you know, you're operating the software or you release the software for internal employees to see whether you know, the traffic, when is it doing good when it holds when it's getting traffic onto it. Is it doing good when normal people are doing arbitrary tasks on your software? And then you are also continuously monitoring it to see if you know, your task is or your application is functioning properly, and if it is not functioning properly, you're basically creating a log of events which are happening, right? Which this is called monitoring. And after monitoring again comes the planning phase, which means if you get any kind of feedback from the monitoring part, you again start planning it, how to do it, how to solve this kind of a problem that you're getting in the monitoring phase, and then code your way in, build the code, again test it, again release it to the ops guy, and this goes on and on until you get the perfect application. And there is no perfect application, guys, right? Always there will be new requirements coming in, always there will be some bugs, always there will be some security patches, and therefore this life cycle goes on and on. So this is what DevOps is, guys, right? And if you were to think about it, how is it solving the problem between the dev and the ops guys is by automating this life cycle. Basically, that means that now the developer does not have to give the code to the ops guy. It will basically be given through a tool which we have, so there is a tool called Docker, right? So basically the dev guy will enclose his code inside Docker and will push it to the ops team, and the ops team just have to run Docker and this code will run fine, right? There is no problem for dependency, there is no problem for configuration management. Everything happens automatically in this lifecycle. So don't worry if you don't understand exactly what DevOps is, because in our next slides we're going to discuss how it actually works, right? So going forward, now let's discuss how the DevOps lifecycle actually works, right? So if you were to that infinity sign that we had, it if you were to condense it, or if you were to expand it, so that DevOps lifecycle diagram that we had, the infinity diagram that we had, if you were to expand it, it would look something like this, right? So you have something called as planning, you have something called as coding, building, and testing. Now this used to happen on the developers side, right? And then we go on to the ops side, where we have release, we have deploy, you have operate, and then you have monitor, right? So in between this, we have to integrate this part of the developer's side to this side of the operator side, and this is done using continuous integration. Now what is continuous integration we'll discuss in a while, but for integrating the developer and the operations guys, we use continuous integration, right? Now before moving on to what is continuous integration, let's pay attention to what we have over here as well, right? So the planning and coding phase, we contribute, or we collectively call it as continuous development. What is continuous development? I'll explain you in a little while. Building and testing, we call it continuous testing, okay? Releasing and deploying, we call it continuous deployment. Operation and monitoring, we call it continuous monitoring, okay? So you start with planning, you do coding, you build it, you test it, you then release it to the ops team, then you deploy it, then you operate it, and then you monitor it. And this gives rise to 5 stages, that is continuous development, continuous testing, continuous integration, continuous deployment, continuous monitoring, which again goes back to continuous development. Now let's understand these terms. Let's understand what is continuous development, testing, deployment, monitoring, and integration. Okay. So this is the life cycle, guys. Now, why are we calling it continuous? Continuous basically means it goes on and on, right? It never stops. So like I told you in the diagram for DevOps, that the cycle goes on and on. It never stops. The product is always being developed, right? It is always in some part of the life cycle. So if you were to explain continuous development and continuous integration, continuous testing, this is the best way to learn it. Okay, so we have a developer who basically will be pushing his code to a version control system. Okay, and this version control system will basically, any changes in this version control system will be taken up by a continuous integration tool. Okay, so what is a continuous integration tool? A continuous integration tool does nothing but it joins each of these stages to each other. For example, if I have to go from continuous development to continuous testing, and if this happens in separate softwares, continuous integration will join these and this, right? Continuous integration will join testing and then deployment. Continuous integration will join monitoring and then again coming back to development. And how does this happen? It happens like this. So there is a software which basically does continuous integration. Okay, let's understand just this as a black box. This is a software which does continuous integration, and the function for this particular software is the moment you push your code to a version control system. This version control system is nothing but a software which takes care of storing your code. Okay, so the moment you push your code to a version control system, or you change your code in the version control system, the continuous integration tool automatically identifies, okay, so there's a change in the version control system. So what it does is it takes this code and it builds it on the testing server. It first builds it and tests it on the on the testing server, and this is called continuous testing. Reason being, every developer who does this, continuous integration does the job similarly. right? So if there are 100 developers in the team, so for every developer, if we configure a version control system that for every developer it has to test the code, it will always do that. Okay, so every developer who's doing a version control, who's pushing his code to version control system, continuous integration software is going to test their code on the testing server, right? And this is the reason it's called continuous, right? Because it happens continuously. Okay, so continuous development, we push our code to version control system. It is identified by the continuous integration tool. So the first job that continuous integration tool does is it pushes onto the testing server the code where it is built and tested, and if the test succeeds, continuous integration tool pushes it on the production server. Okay, now either if it's on the production server or if it's on the testing server. Now if on the testing server there are some bugs which are identified, the feedback is given through continuous monitoring to the developer. Or if the production server, if there are some problems on the production server, or like I said, when you deploy your code on the production server, it basically gets available to the world and it gets continuously monitored, right? For any kind of problems which are occurring, it gets continuously monitored and the logs are generated, and these logs are being stored somewhere using continuous monitoring. So your production server is continuously monitored for any kind of activity which is happening on it, and the logs are being generated. Now the developers, the team, now when I go back to the developer, why am I coming back over here? Because this identifies, or this tells us basically now that now when the development team is done with the release and now they have to see what other work I have to do, all they have to do is check the logs from the continuous monitoring tool, right? And they'll be able to identify, so okay, so this and this is causing a problem, this and this is causing a problem, and also the users are saying that, you know, we should have this feature. The client also came in, he also wants some features, so they plan a release, right? And once they plan a release, they again start coding, and again once they're done with the code, they'll push the code to version control system, which will be identified by the continuous integration tool, which will then automatically test it. Once it's been tested, if it's successful, it will push to the production server. Again, the logs will be identified by the continuous monitoring stage. Again, it will go to the developer after planning, and then he'll code his way into version control system, and the life cycle goes on and on, right? So this is exactly how DevOps work, right? Now let's look at each of these stages independently to understand what exactly happens in continuous development, what exactly happens in continuous integration. Okay, so in continuous development, you basically push your code to a version control system. The version control system could be a software like Git or a software like SVN. Right now, when the moment you push your code to the version control system, it basically creates a new version of your code. For example, if you wrote ABC on a text file, right? Now that ABC you wrote and you upload it on the version control system. So this was the first version. The version control system automatically makes it version 1. The moment you make some changes and again push it to the version control system, what happens is it creates, the version 1 was the text file having ABC. Now the new version that you have pushed, it becomes version 2 and the file would be ABC and probably whatever changes you have made to the file. Okay, so it creates a new version, and at the same time it also holds on to the previous version, so that in any case, in any problems that you might have in the future, if you want to revert back to the previous version, you can easily do that, right? And that is why we have version control systems like Git and SVN, and continuous development is an integral part of pushing code to your version control system. Okay, now this was continuous development. Then you have continuous integration. Now what is continuous integration? This is nothing but integrating your life cycles with each other, right? For example, once you push the code to your version control system, it obviously has to be picked up and pushed onto the testing server for testing, where it could be built and tested, right? So all these life cycles are integrated, or there is someone who is doing the manual job of a person of taking code from one stage and pushing it onto another, then taking the results from there, pushing it onto another, then taking the results from there, pushing onto another, and that manual effort is being done by a tool which is called the continuous integration tool. Okay, then you have continuous deployment. Continuous deployment basically means you will deploy your code onto a particular server. It could be a testing server, it could be a production server, and deployment basically involves putting the right kind of software on it and then pushing the build onto your server so that it has the right software environment where it will function, right? And again, installing softwares on system and everything is also automated using a tool which is used in continuous development lifecycle. Okay, then we move to continuous testing. Now continuous testing is again a lifecycle stage wherein you continuously test your software. So like I told you guys, in this what happens is you continuously build and then test your code. So your code is pulled from the version control system. It is built. So when I say built, it basically is converted to an executable file, and this executable file is then run, right? Now the continuous testing, how it happens is you create testing suites which are basically pre-installed in the testing server, and the moment it gets a new executable, all those test suites are executed on this particular executable file to check if all the tests are passed or not, right? And if all the tests are passed, it is then again picked up by the continuous integration tool and then pushed onto the production server. Once it reaches the production server, again it gets monitored, right? It gets monitored for user activity, it gets monitored for any errors, it gets monitored for any user comments on version upgrades, right? On version upgrades, or you can say any feature requests. So all those feature requests, all those errors, all those logs are then visualized or then are then stored inside a monitoring tool, right? And this monitoring tool helps us in sorting these logs based on what we want. It'll basically sort it on the basis of general logs, it'll sort it on the basis of error logs, it'll sort it on the basis of feature requests, right? So it becomes a one destination stop for you where you can check and plan your day ahead or plan your team's work for the near future. Okay, so this is continuous monitoring. So these were all the life cycle stages of DevOps, guys, and this life cycle stages basically make it possible for us to have shorter release cycles because all these stages are automated, right? And these are automated using tools, and these tools we'll be discussing in our next session, where we will get an introduction to all the tools which basically come together to create a DevOps. Right. So far we have discussed the DevOps methodology, how the DevOps lifecycle work, but they are incomplete without their respective tools, which will map to each of the lifecycle stage in the DevOps lifecycle. Okay. So let's go ahead and start discussing these tools with their respective stages. So the first stage that we saw was continuous development. Now continuous development is implemented using version control systems, like I told you guys, and in most of the companies, the most used version control tool is Git. All right. So Git is a version control system which we'll be also using in this course, right? And it is basically used when multiple people are working on one particular project. Right, so it is great for team collaboration. It is great for tracking changes, and is absolutely awesome on command line. All right, so this is what we are going to learn in this course. So for Git maps to the continuous development lifecycle stage, then we have continuous integration. Now you heard a lot about this continuous integration tool when we were discussing in the DevOps lifecycle, and the tool is called Jenkins, right? So Jenkins is basically an open source tool, right, which is used to implement the continuous integration features that we saw in the DevOps lifecycle. So in this course, we'll be learning Jenkins, and there is a separate module on Jenkins that we'll totally devote to explain different features that you can explore in Jenkins, right? The next stage is continuous deployment, and continuous deployment basically means two things. It means configuration management, and it means virtualization and containerization. So we use Docker for virtualization and containerization, and what exactly Docker does is, so the problem of running your code on one system and not being able to run on another system is what is solved using containerization. So what containerization basically does is, it wraps your code along with the software dependencies, and it all these software dependencies and code is wrapped around by a container, right? So a container is a physical entity which will basically wrap your software dependencies and your software, and it will, if you run that container on any other system, it will run as if it is running on the same system that is on the developer's computer. So a container is an executable form of an operating system which can be run on any system. The only pre-requirement is that you should have Docker installed on it, right? Similarly, you have configuration management. Now configuration management, what is configuration management exactly? So say you have a computer, you have a freshly set up computer on which you have some operating system installed. Now if you want to test your application on that system, what you have to do is you first have to install all the softwares on it, right? For example, like I said, you would need Docker for your container to run. You probably would need an Apache server. You would need Python, or all these softwares which have to be installed can be installed using configuration management without even touching that remote computer or that freshly set up computer. And that is possible using tools like Puppet and Ansible, more of which we will be seeing in our course as we progress in our number of modules. All right. Our next stage is continuous testing. Now, continuous testing, as we learned, was all about creating testing suites which would automatically test your code once it gets built on your system, right? So all these automation testing suites can be created using the Selenium software, right? So we will be learning the Selenium WebDriver in this course as we move along, and we will see how we can create our automation suites in Selenium for testing our applications. Okay, so this was about continuous testing, and then next we have continuous monitoring, wherein your application is continuously monitored and the logs are created. Any errors are also monitored, right? So all of that is done using Nagios. So Nagios basically gives you a dashboard with all your services listed on it, and those services can exist on any system outside the network or inside the network, and all these services running on it can be seen on the Nagios dashboard. Okay, so it's a great tool for monitoring your application. It's a great tool for gathering user data or user activity data at a one-stop destination. Okay, so that is what Nagios is all about. And this brings us to all the tools. So these were all the tools that we will be discussing throughout the course, right? And this brings us to the DevOps tools lifecycle. So you saw the DevOps lifecycle earlier, wherein you had a developer and the developer was basically pushing code onto a version control system. This is a replica of that figure, and in this figure we have just replaced the tools with the life cycles. All right, so now what the developer does is he pushes his code to GitHub. From GitHub, Jenkins automatically detects that on GitHub your code has been changed. It pulls the code and pushes it onto the testing server, and it installs all the softwares required on the testing server, and the testing suite that has been built on the Selenium is already present on that testing server, right? So Jenkins pushes the code here, the code is built and tested over here. If it goes successful, Jenkins again pushes the code to production, right? And on the production server, Nagios continuously monitors it for user activity, how many users are logged on, what the users are saying about it. All of that information is saved inside Nagios, and that information can actually be seen on the Nagios dashboard by the development team, and they can make a plan for the next release, what all features they have to include, what all fixes they have to do, right? And once you do that, you again start on with your next release. So this is what you do when you are working with the DevOps tools, and this portrays the whole DevOps lifecycle that we have in a company, in any arbitrary company which is using DevOps. All right, so guys, this brings us to the end. So it was a theoretical session for us, but I'm sure you must have gotten an actual idea about how DevOps actually works, right? So thank you guys for attending today's session. Have a great day ahead, and goodbye.